Okay, so let's go ahead and begin. So welcome everybody. My name is Josh Broth. I'm from Sumo Logic and I'm the lead technical trainer. And what we're going to be going over today is Sumo Logic certainly, but specifically the search mastery using the certification class as a guide for our agenda for today. So let me go ahead and just change screens here. There we go. Sorry about that. So previously, you've hopefully joined one of our sessions, and hopefully you've joined us for the fundamentals class where we go over the basics and fundamentals of Sumo Logic. Well, today we're going to be doing search mastery, which is going to get involved with the query language. We're going to see how it works and see some various operators that are going to be useful and really just do some labs together. So in the fundamentals class, if you joined us for that previously, you know we did a demo. We did a presentation. I had a couple slides in there, and then we did a couple labs towards the end. Today is going to be pretty much or 100% labs. So we're going to be doing labs together. I'm going to do them on my screen. You'll do them at your device. So let's go ahead and get you logged into the lab environment. You may have used the credentials before, but I'm going to post them because I don't expect you to remember them. So let me grab them. So they are located right here. So the website we're going to be going to is service.sumologic.com. The username we're going to be using, we'll be using the same account, is going to be training plus labs at sumologic.com. And then the password is going to be sumo labs, capital SUM 0, capital L ABS exclamation point. So go ahead and start to log in. I'm going to go ahead and put those credentials in the chat of Zoom as well, just in case you need them later or anyone else joins us. And if you need any help throughout today, go ahead and post it in the chat. I'm doing this session by myself, which is great. But so I might be a little slow just to look at the chat, but I'll keep an eye on it. So go ahead and log in. And if you want to start to already dive into the labs, like I said, we'll do them together. But if you want to follow the steps of going to the actually, I just need to change this screenshot. It's a little out of date. But if you want to go to certification and go to search mastery, and then there'll be a section for hands-on labs, you can go ahead and open the labs. But I'll show you how to do that in a moment. So give everybody just another minute to log in. Training plus labs at sumologic.com. Capital SUM 0, capital L ABS exclamation point. So once you log in, you should be on this screen, which would just be the home page. Go ahead and click on certification. And then under search mastery, which is the green one, there'll be a section for hands-on labs. So go ahead and open up those labs. And so the way we're going to work today is you'll have one tab for your the application, so actually Sumo Logic. You'll have one tab for the lab itself, and then you actually might have a third tab with the Zoom session going on. And so the way we're going to do these is just really just one by one. All these labs have valuable portions to show that introduce new outlier or new features, new examples. So I think you'll find these useful. So if everybody's logged in, I'm going to assume everybody is, or at least nobody's screaming. So I'll take that as a positive. And so I'm going to go ahead and start with, lab 1 and work through lab 15. So lab 1, if I scroll to the very bottom and go to lab 1, search basics, metadata, and keywords. The way I'm going to do these labs today is for each lab, and labs may have more than one component. So this has lab 1, 1-1, 1-2, etc. We're going to go ahead and go through each one. So each lab or each section will have kind of a problem we're trying to solve for, and then we'll be provided with the query that we're going to use. So for today, we're not going to be creating our own queries. Hope that's not a disappointment, but we found this is an effective way to learn to take the queries that we've provided and see how they work. So we're going to look at them line by line to see, this is what this line is doing. This is what the next line is doing, and so on. Before we start, looks like a question. So you're going to want to make sure that you log in to the Sumo Logic account first. So you're going to want to use these credentials. And then once you're logged into the training account, then you'll want to go ahead and go into certification and hands-on labs. You're not going to want to take these hands-on labs directly from your corporate or your personal Sumo Logic account because you won't have access to the lab data. The infrastructure or the environment's exactly the same, just we've preloaded this with lab data so that we can mess around and experience how the system works. All right, so if everybody's together, we're going to go ahead and start with lab 1-1. And so we're looking at search basics regarding metadata and keywords. Now, these are pretty basics, but basics are a good place to start. So that's why we're going to start here. So in the first lab, we the system wants us to look for all messages with the source category labs Apache access for the last 15 minutes. So how are we going to do that? Very simply, we're just going to take the query, copy it, go back into the interface, go ahead and do a new log search, and then just paste the query in. When we run it, the system is automatically going to choose the last 15 minutes by the default, so we don't have to modify that. And now we're doing what the system is asking, what the lab is doing. We're now saying, take all the lab Apache access data from the last 15 minutes and show us those log messages. And that's what we see down below. In the middle-ish screen portion of the screen where I'm trying to highlight right now, you'll notice the results. And so your results might not match mine to one, and that's perfectly fine. Keep in mind when I click start, my 15-minute window is defined as such. If you click start even 3 seconds later, your 15-minute window is a little different than mine. So it's not important for today that your numbers match mine 1-to-1. It's really more important that you know almost why they don't match 1-to-1. So I just wanted to point that out. All right, now lab 1-2, and that's the numbering scheme I'll use, 1-2, -3, etc. Now in 1-2, we're going to modify our query. And this time, instead of looking just at lab Apache access data, we want to identify client errors. And the way we're going to go ahead and identify these client errors is to look for a 404. So I can either grab the whole query, or I can just grab the portion that's a little bit different, copy it, and paste it in. Now, I'll go ahead and run it. So what we're saying here is look for the Apache access data or through the Apache access data from the last 15 minutes, and of that data, look for the string of 404. Now, a couple things about this query are really more the results, I guess you could say. The first thing is this end. The end is going to be assumed. So if you want to include it or you don't, the system is going to act exactly the same. So at that point, it's really more just personal preference or style. So if you want to leave it in or not, totally up to you. The second thing is this 404. Now, what we were doing with the lab is we're trying to identify client errors. And so to do so, or the way we're doing so, is we're looking for that string or those letters or numbers, rather, excuse me, of 404. Now, we're primarily focused on this portion where the status code would be. However, if 404 showed up in the milliseconds column, for example, or field, that would fulfill this request. So at this point, we're just saying look for 404 anywhere in the log message, not just in the status code field. Now we're going to get to, and you probably have seen before using parsing and field extraction rules and other things, how you could say status code equals 404. But at this point, we're not up to that step. So just want to be straightforward and kind of transparent. We're just saying look for that string, wherever that string resides in the log message. And that's why we see those 404s highlighted down below. Now in 1-3, we're going to introduce the idea of Boolean logic, which is going to let us start to use wildcards. So what we're trying to do here is use that Boolean logic to search for log lines matching or containing error or check out. So we're trying to look for those 3 words or strings within the log message. So how do we do that? Well, grab the query, paste it in. I'm going to do a new log search, and I would recommend doing a new log search for virtually every query that we're going to do through the labs, but personal preference. So what we're doing here is we're saying look for the source category lab Apache access, and from that set of data, look for the word or the string error, or check with the star. And check with the star is going to look for check. It's going to look for check out. Theoretically, it would look for anything else: check out, check in, check up, but that will fulfill our request. So when we click start, the system's going to look through that access data, look for check with a star, so anything that starts with a check or error, and then highlight that keyword below. So that's why we see checkout highlighted down below, because it fulfills that kind of mission, if you will, of the query to look for check with the star. Now in 1-4, we're going to introduce a new source category, or I guess new to us today at least. In this case, we're going to look for lab Apache error data, and we're going to look for it for the last 45 minutes. So to do so, grab the query, paste it in. But there's 2 things to focus on in this lab. The first is the fact that we want to select only the last 45 minutes. So what we can do here, and what this lab is reminding us of, is in the relative time period, there are last 15 minutes, last 60 minutes, etc. There's not a last 45 minutes. So how do you select last 45 minutes? Well, that's where the syntax of minus 45M is going to work here. So now when I click start, I'm saying look for or look through the Apache error data from the last 45 minutes and show those log messages down below. Something else to point out on this screen is you'll notice, and you may not have noticed by default, but now that I'm pointing it out, you certainly will, the word error is in red down below. So each log message has the word error in it, and it's in red. Now, the question or the thing I want to show you is why it is in red. You might think it is automatically in red because we're looking at a source category that has the word error in it. Now, that would be incorrect, but it would kind of be a fair assumption. The reason it is in red is we at Sumo Logic have just pre-populated the fact that the word error and the word exception are automatically in red, so that theoretically, if you had a long list of these different log messages, your eye would kind of naturally, or hopefully naturally, be drawn to those that have the red in it. In the near future, we're going to give you the ability to start to customize that. So you as an organization can say, I want to put the word client in green or notice in purple, or, and start to become a little more creative with that. All right. Lab 1-5 is asking us now to look across two different source categories. It wants us to look across the Lab Apache access data and the Lab Apache error data. So I'm going to grab the query, paste it in, but before I run it, I'm going to just talk about it. Well, I'm talking about all these, of course. So the goal here is to look across two different source categories. Before I run this, I just want to talk through what would happen if I was to remove the OR. Now, if I was to remove the OR, and I guess I want you to think just for a second, what would happen if I was to click start? What results would I get? Now you're thinking two things. You're thinking I would either get results from error as well as access, or that I would get no results. Probably thinking one or the other. Now let's explain why you're thinking those, I guess. Since there's no OR here, there's going to be the end, or at least the assumed end. And if I was to run this right now, I do get no results. And the reason I get no results is because I'm saying look for data that resides here and at the same time resides here. Data can't reside in two different places at the same time. So what we do and why we're showing this is using the OR, we're saying look for data that resides here or data resides there. And now when I run this, I'm going to get both source categories. I can verify that I'm getting both source categories by using the field browser. So if I go to the field browser on the far left, and actually let me get rid of this black bar, I see a field for source category. If I click on it, I now see the two values for source categories. So this is showing me most of the data that's being pulled from the last 15 minutes is access and some of it's error. Now in lab 1-6, we want to express this in using wildcards. So what we can do is grab this query, copy it, and just paste over it, or do a new query window. And what we're saying here is grab source category Lab Apache anything. Grab Lab Apache access data, Lab Apache error data, and theoretically, if there was Lab Apache random, that would be pulled up here as well, because we're saying look for anything under the Apache. We can verify once again what source categories are being pulled, and seeing once again that it's just those two that I mentioned. Now, the last step in this lab, or these labs, is 1-7, which is going to introduce LiveTail. So LiveTail, as a reminder, I'm going to take the query, I'm going to paste it in, but I'm going to talk through it. So when I click start right now to run this query, I'm looking at old data. Now I'm, at least in my office, I'm virtually kind of using quotes when I say old, because old is a relative term. This is data that's come in, it's been ingested, and it's been, if you will, sitting around for 15 minutes. Now, it's not really old in the scheme of things, but it's data that's come in and been processed and just waiting there. Now with LiveTail, by clicking on LiveTail, what we are now seeing is data as it becomes ingested into Sumo Logic. So once this starts to populate, and this is a lab environment, so we don't have a ton of data coming in. Oh, here we go. This is now seeing data as it comes in. So coming in, etc. So LiveTail is going to be helpful for that use case of if you want to see data as it's being ingested into the system. Maybe you set up a collector to bring in your data and you're not seeing it in your query window when you do a search. We'll come to LiveTail to verify, is data even coming into the system? If it is and you can't search for it, you might have one issue. If you can't even find it coming on this screen, you might have another, meaning the data is not even coming into Sumo Logic. So LiveTail is going to be helpful for those use cases of where you want to see or where you want to check to see if data is coming into the system. Many of you will never use it again. So I did want to point it out, but some people just don't need to use it, and that's perfectly fine. All right, let's go into lab number 2. So in lab number 2, we're going to be going over simple parsing, grouping, and filtering. And so what we're going to do is continue kind of where we just were. So in lab 2-1, we want to search the Apache logs, access and error logs for the last 15 minutes, and then count the results by source. So how do we do that? Well, kind of know how to do it. We're just going to paste it in, but let's talk through what the query is doing. So in the first line of the query, we're doing just as we did a moment ago. We're saying grab that source category, lab Apache, whatever. The second line, I've commented off just for now, which means I've turned that line off. So when I ran this query, it says if the second line didn't exist because I want to go line by line. But now that we have our data, now we can say count by source. When we do count, we're doing aggregation, we're doing math, very simple math, but still math. And so we get the results of that math in the aggregates tab. So here we see the count by source is mostly Apache access data and some Apache error data. Even though, or not even though, but in addition to getting the aggregates tab, we still have that original messages tab to see those raw messages, or we can look at the aggregates, the results. So just depends, what view you're looking for. Now in 2-2, we're going to modify our query, and I'll just grab the whole thing, because we're going to introduce parsing. And we're going to introduce parsing the IP address using regex in this example. So I'm going to grab the whole query, paste it in, comment lines off, and then go line by line. So in the first line, I'm grabbing all that Apache data again. And just to verify that I am, there it is. Now in the next line, I'm using regex to identify an IP address, because what I have here, and sorry, it's taking a little longer than it should. Oh, let's see, I think I'm having an issue with my Wi-Fi. There we go. So what we have in here is we have IP addresses located in some of these log messages. And so the goal here is to tell the system how to identify an IP address. So how am I going to? Well, here we're going to use regex, or regular expressions. Now, regular expressions are a pattern matching system that is not Sumo Logic proprietary. It's a open source, I guess, almost at this point. And so what we're doing here is we need to tell the system how to locate this as an IP address. Because I recognize an IP address because I see, the dots, and hopefully you do too, but we need to tell the system how to. And that's what we're doing with this second line. We're using regex, or regular expressions, to parse. So as it says here, we're extracting complex data to create field labels. So basically, we want to create a field label called IP address. We want the system to identify an IP address. Well, how is it going to identify an IP address? Well, the way we're going to train it to is to look for this string, or this pattern rather, excuse me. So to look for number, dot number, dot number, dot number. And more specifically, we're saying look for a digit with 1 to 3 characters, dot 1 to 3 characters, dot, etc. So now when I click start, the system's going to go ahead and do that. And when it finds an IP address, it's going to parse that IP address out. So now for each log message that has an IP address, I have an IP address field and a value. Now I can go ahead and count by IP address, because the system knows what an IP address is. Since I'm doing count, once again, I'm doing math, I get that aggregates tab. And now I can see over the last 15 minutes, there were 1,900 hits or visitors or transactions, or however you want to count those log messages related to this IP address. 3,000 for this IP address, and so on and so forth. Now we can continue modifying the results here to clean up the data by using lab 2-3. So what lab 2-3 wants us to do is two things. It wants us to filter out those with the count less than 2,500, and it wants to display our results in a pie chart. So the first thing we can do is modify the count, because right now we have counts ranging from 214 to 6,800. Well, as the exercise said, what if we want to filter out those that are less than 2,500, basically keep those 2,500 or greater? What we can do is say where count is greater than 2,500. When I click start, the system's now going to look at all these counts. If it's above 2,500, it's going to keep it. If it's below 2,500, it's going to drop it. And so that's why I now have, instead of, I think it was like 15 IP addresses, now I have 6, only those that are above 2,500. And then I can go ahead and put this in a pie chart. So the system's reminding us, or the lab's reminding us really, hey, you can look at this data in this tabular view, but maybe you would prefer a bar chart, a line chart. And in this case, we want to use a pie chart. And if I zoom out a little, then I see the pie chart represented in a similar manner, where I see the slices with the value of the IP address, the count of those occurrences, and then even the percentage breakout. Okay, good. Let's go ahead and move on to 2-4. Now, in this case, what we want to do is write a new query that's going to identify the top 10 source IP addresses by bandwidth usage. Now, before reading the rest of the lab, and the solution is right here, so it's given to me, but the way I want to read this is kind of like a math word problem. Because what am I trying to solve for? Or really, what am I trying to have the system solve for? Well, I need to tell the system how to identify an IP address. I need to tell the system how to calculate bandwidth usage. And I need to tell the system how to find the top 10 IP addresses by bandwidth usage. So if you think of this as like a word problem in math, it's almost your kind of X, Y, and Z, or what are you trying to solve for? So how are we going to solve for that? Well, the query's here, but let's grab the query and talk through what it's doing. So I'm just going to take the whole thing, another new log search, paste it in. I'm going to comment off these lines, it's just so I can go one by one. So in the first line, we're grabbing that Apache access data, like we'll do many more times today. In the second line, we're going to parse out the IP addresses. So as I just talked about, we're going to tell the system to look for that pattern or that string. And when it finds it, it's going to identify that thing or that string as an IP address. So that's why we have all these IP addresses now. Now, the next part is it might be a little tricky, but I mean, we show you how to do it with the explanation here, but let's show you what it's doing. So the goal here now is to look for the size in the log message. Now, the size is going to be right here. These are the sizes, or the bytes. So how many bytes were being transacted back and forth when we went to visit a website. So how do we get the system to identify this? Now, we could do this many different ways using regex, using field extraction rules, but what we want to use here is we want to use a parse anchor. So what we're doing here is we're saying, look for a space, look for a 200, look for another space, then whenever you find that is going to be a size, and then look for another space. Now, the reason we're saying look for a 200 is here is the status code. But we only want to show the status codes that are equal to 200 because a 200 is indicative of a successful connection. So when I click start now, the system is going to look for those log messages that now have a space, a 200, a space, and that next thing is going to be a size. And so now that I've run this third line, now for each log message, I get the IP address and I get the size. So now for each log message, I have those two pieces of information, which is good, but the goal here is looking for the source IP addresses by bandwidth usage. Right now, I'm parsing out those byte sizes, excuse me, as well as those source IPs, but I need to now have the system start to really aggregate that data or total it. So what I'm doing here on this fourth line is I'm now saying, take the size, so whatever 4-digit number is there, and add it up, use sum, and call the result total bytes. But do it by IP address. So now when I click start, since I'm doing math, I'm going to have the aggregates tab. And what I'm going to see is for each IP address, the total bytes. So all those 4-digit numbers added up. Now I have 17 of them, 18 of them, ranging from 27 million bytes to 4 million bytes. But my goal was to find the top 10. So how am I going to find the top 10? Well, that's what the last line is going to do. What do I want to find, or what do I want to look for? The top. Top is an operator. The top X, the top what? Well, in this case, the top 10. I want to find the top 10 what? Top 10 IP addresses. How do I want to find those top 10 IP addresses? Do I want to find them by count or by value? Well, no, I want to find it by total bytes. So now when I click start, the system's going to take those IP addresses, sort them, keep the top 10 with by total bytes, and drop those bottom 7 or 8. And now we fulfilled that request. And now we're finding what the system told us to, or the lab told us to. All right, cool. No questions, so let's keep rolling. Lab 3 is going over parsing options. You're certainly welcome to follow along on these next steps, but I'm really going to more kind of talk through them because they're really more like features, but feel free to play along. So with Lab 3-1 and -2, I'm going to grab just the set of data and then talk about what this feature does. So let me just grab the source category and paste it in and talk through it. So in this case, I'm using a different set of data. Previously, we were just using the Apache data, and this time we're using CloudTrail data. Now, CloudTrail data, AWS CloudTrail data, you may be familiar with, you may not. Doesn't really matter either way. But what I want to show is the fact that the data is formatted differently. Now, if you're familiar with it, this might be obvious to you, but if you're not, which I wasn't, before I came here, I wasn't aware of this pattern. So let me show you what it's doing and how we can take advantage of it. You'll notice these log messages are in a different format. So if I looked at the Apache access messages, they look like this, kind of one big line of stuff, text. However, the CloudTrail messages have a different format. For each field almost, they have a field and a value. So here's a field called source IP address, and here's a value. Here's the AWS region, and here's the value, and so on and so forth. Now, what if we want to parse out the IP address, or we want to parse out the AWS region? How do we do that? Now, there's a couple ways to approach this. We could use regex, where you could say look for number.number.number.number, and that's how we're going to identify an IP address. We could use a parse anchor, like we did with the 200, where we say look for source IP address : quote, and whatever's in there will be an IP address. We could have a field extraction rule that does this automatically for us upon ingestion. Or we can do something a little bit different because these log messages are in a JSON format. Now, we may know that they're in a JSON format just because we know natively CloudTrail messages are. We may identify this structure as JSON, or we may just see this really big clue up here that says expand JSON. But either way, they are in a JSON format. And since they are, we can take advantage of the JSON operator. So to parse out all these fields, and you'll notice in my field browser before I do the second step, I don't have any fields or just the fields that are there. But now I can do very simply JSON auto. As it says right here, it's going to automatically extract the values from JSON. So now when I click start, the system is automatically going to parse out a field for source IP address, for AWS region, and so on and so forth. And now if I want to count by AWS region, very simply, I just do count by AWS region. And I do have to spell it correctly. And now I see the regions and those counts. So this JSON operator is really helpful for JSON formatted log messages, and is so obvious to use. And I don't mean obvious like you should have known about it already, but what I mean by obvious is it's such a obvious thing that we want you to do. We're actually going to in the near future have this run automatically, so that when we identify JSON log messages, we'll automatically parse out all the values for you, making it even easier. But that's how I can use the JSON for my advantage. If you're ever given the option by whoever, I guess, what file or what format you would like your logs to be in, this is a reason why you may want to use JSON. Now, there may be other reasons not to, because JSON files can be larger, which can charge more for billing. I don't want to get into all those kind of subtleties, but this is certainly one benefit of using JSON is these fields get almost auto-parsed and just save you time, which is, always the goal, certainly. So that's the benefit of Lab 3-1 and 3-2 is introducing that JSON operator. Labs 3-3, 4, 5, and 6 go together. I'm just going to grab 3-6 and grab the whole thing and just talk through it. Because what we want to show here, let me just comment off these lines real fast. So what I'm doing first is I'm looking at this Lab Apache error data. Now, we did look at it for a second earlier, but now we're going to use it again, but look at something a little bit different in it. What I want to focus on this time is the fact that some of these log messages have a client, and when I say client, actually the word bracket client space, and an IP address, and some of them do not in the same spot. So client IP address, no client IP address. No client, sorry about that. No client IP, well, sorry. So in 23, there's an IP address, 24, there's an IP address, but in 16, 17, 18, there's not. And I'm talking about in this spot over here. So if I tell the system to parse using a parse anchor, where I say, look for a bracket, look for the word client, look for space, look for something, identify that something as a client IP address, when I click start, the system is going to do what I tell it to. And it's going to retrieve only those messages that have bracket, client, space, something, which is good because now I see IP address and I have a field for IP address, IP address, IP address, so on and so forth. The problem here, it's not a problem, the system is doing what we tell it, but we are losing or dropping those messages that do not have an IP address because we're telling the system, don't bring those messages back. But what if we want to include them? What if we want to see what messages are being dropped? How do we do so? Well, very simply, at the end of the line, we're going to add an option called no drop. And what no drop tells the system is to try and parse this message if it can parse out the IP address, like the first two lines. However, if it can't, still show the log message like it does in the third line, but since there's no IP address to display, just show a blank or a null as the value of client IP address. So no drop is going to be really helpful for you for when you start to create your queries, particularly the parsing section of them, and you want to see what you're leaving out, either intentionally or unintentionally. Because let's say I created my parsing anchor statement here and I added an extra space and I click start. Well, now the system is telling me there's no IPs. Now, I could take that at face value and say, okay, there's just no IPs. Or what I would recommend doing is running the no drop to see, are there any IPs? And then realizing, hey, here's an IP. Why is this not being parsed out? And then realizing, oh, it's because I have an extra space in there. And then just modifying my query. So no drop is going to be helpful for you to troubleshoot those queries to make sure you're bringing back everything you want to. And if you are, great, just keep continuing on with your query. If you're not, though, you may want to come at the query a different way, a different angle or a different way. So now we have these fields for IP address, and we have either values of an IP address or a blank. Now what I want to show here is the fact that you can use the where is blank to it's almost seeing the opposite of a no drop. Because now what I'm saying is only show me where the IP is blank. So now when I click start, like I described, it's almost the opposite because now I only see log messages that do not have an IP address. So, I mean, you're not going to be using where is blank every day, although you certainly may, but it's something we just want to show you as a way to, see what is being dropped and what isn't being dropped, and then just deciding, is that okay or not? All right, cool. Lab 3-7 and 3-8 go together. I'm just going to grab 3-8 and just talk through the whole thing. But what we want to show here is the fact that you can parse a field and parse it even further, which I think is kind of, I was going to say cool. I don't know how cool it is, but it is quite a helpful feature. So in this example, we're using GitHub data. And GitHub, just for you, in case you're not aware, but I feel like most people that attend these calls are, but if you're not, it's fine. It's not Sumo logic data, it's an outside source. Basically, it's a website where people can go and share code, so you can upload code and download code and make changes and track it, and it's used for kind of group projects. So within GitHub is the idea of a committer, an individual who has committed or submitted code. So here what I see is information about this submitter. I see their name, I see their email address, and I see a username. Well, let's say I wanted to parse out these email addresses because, I don't know if I need a good reason, but maybe I need to add them to a mailing list, or maybe I want to check their domains, or whatever reason. Now, first, how am I going to tell the system how to identify this thing as an email address? Well, that's what I'm doing on the second line here. I'm using the parse anchor, where I'm saying, look for the quote, look for the word email, look for the close quote, look for the colon, look for the open quote, et cetera, et cetera. And when I click start, the system's now going to look in that spot, look for just text and bring it back and identify that as an email. Now here we have emails, but here, let's see if I have a good example. It's a good example. Here, for example, the email address is just a bunch of string of characters, not what we'd typically expect to see as an email address with an @ symbol. Now, this is not due to Sumo logic. This is just GitHub's probably not forcing any email validation when they create an email for a user or a committer. But regardless, that's what the logs are showing us. So the system is acting correctly in that it's now taking that thing that it found in the email space and extracting it out. But let's say we wanted to now take these email addresses and modify them or validate them. Sorry, tongue-tied today. What we can do here in the third line is say, okay, take that field of email. So the system has now parsed out something as an email. And here we're saying, take that something as an email and look for this pattern within the email. Look for an @ symbol. And if you find an @ symbol, call the thing before it a user or users. And at the end of it, call that a domain. So this is going to serve two purposes. When I click start, the system is now going to look for an @ symbol, and it's now going to extrapolate or pull out the thing before it as a user and the thing after it as a domain. The other thing it's doing is it's also acting almost as a validation for emails, because now it's not going to include that long string of numbers because that long string of numbers did not have an @ symbol, and so that will be dropped. And so this, like I said, is serving two purposes. It's allowing us to parse out or split up the email address, and then it's also allowing us to do some validation. Because now, let's say the goal of this lab or this query was to look for, count the different domains that have committed code over the past 15 minutes. Well, now I can just count by domain, spell it rightly. And now what I'm saying is, over the last 15 minutes, these are all the different domains that have committed or submitted data to the GitHub or committed data. And so that's what we wanted to show here, is the fact that you can parse an email or parse a field out and then parse it even further. Email address is a great example. Another really good example is, let's say you have, and I think I'll show it in a little bit even, let's say you have IP address : port, and that's how you extract the data. Well, you could use that colon as that kind of trigger or flag and say everything before the colon is the IP address, everything after the colon is a port, and then do what you want with it. So I wanted to show that. All right, this next lab is 3-9 and 3-10, and I'm just going to, once again, grab the whole thing and just talk through it. So new log search, paste it in, comment off. Now this set of data is different as well. This is snort data, kind of fun to say, snort. Snort data is not Sumo Logic data either. It's an outside system that's looking at security event detection, I guess, or yeah, security events. Now, what we're going to use this for is to use the parsing of the IP addresses. So what do I mean by that? So here's the log message, and all these log messages basically follow the same pattern. Now, what I want to point out in these log messages is this section right here. Each log message has two IP addresses. So here's IP address 1, and here's IP address 2. Now, what are the different IP addresses? Well, for today, it really doesn't matter. They might be source destination, host remote, IP1, IP2, but the important portion is the fact that, yeah, there are two IP addresses in each log message. Now, if I tell the system to parse out the IP addresses using regex, so looking for that pattern of number.number.number.number, what is going to happen when I tell it to look for IP addresses, specifically in the case where there are two IP addresses in each log message? I'll give you a second to kind of think of what might happen, and now let's show you. When I click start, the system is now going to look at the first log message, look for an IP address, find the IP address, parse that IP address out, and now it's going to consider itself done. It's mission fulfilled. And it's going to go to the next log message and say, can I find an IP address? Yes, I can. Here's the value. Can I go to the next log message, find an IP address, and so on and so forth, which is good. It's doing what we're telling it. The problem is, and it's not a problem, like I said before, the system is doing what we tell it, but the issue here is we're not getting those second IP addresses, because what's happening is the system's coming in, looking for IP address, it finds it, it's done, it goes to the next message. What if we want to include that second IP address? How do we do so, or how do we tell the system to identify it? Well, this is where we can use the string of multi. And what multi tells the system is essentially look for multiple occurrences. Can you find an IP address? So here's the first log message. Can you find an IP address? Yeah, the first IP address is 186.131, and there it is. The second IP address is 10.67133. So what we see is the second line has the same exact log message, and here's that second IP address. So IP1, IP2, IP1, IP2, and so on and so forth. In fact, where it says results, it says we have 2,600 results. In reality, we really have about 1,300 unique log messages. So subtle difference, but the system is doing what we tell it to. Now, this is perfectly fine if you want to treat an IP address as an IP address as an IP address, which many times you do. However, many times you don't. In the case where I was just describing, we want to do source IP versus host IP, or source versus remote. So what I want to show now is how to do that scenario. What if you want to treat those IP addresses differently? Now, this is an example where parse anchor would work out. So what I'm going to do is comment off this second line. And what I'm going to do now is highlight the TCP through that second IP address. I'm going to right click on it. And I'm going to now use the UI to parse this selected text. So I'm going to take this first thing, this thing, turn that into a field, that into a field, and then finally that into a field. And now at the bottom, I'm just going to call them, whatever I want. IP1, comma port 1, comma IP2, comma port 2. And now when I click start, now I would get probably what you'd more expect, where now for each log message, I have IP1, IP2, port 1, port 2. And now I could say, show me where, the difference between IP1 or IP2, or, whatever you want to do with this. So I wanted to show both ways. Using the multi is fine if you want to treat all IP addresses the same, which depending on what you're doing, you may, or if you want to treat them differently, this is where you need to come kind of as a different approach to the query, where parse anchor is going to be perfect for that. Okay. Now, the last thing that we want to show in Lab 3 is field extraction rules. So I'll just grab this query, but just point these out. Now, hopefully you've seen field extraction rules, but if you haven't, let's introduce you to them. So let's show first how we know if they're working. What I'm doing here is I'm commenting off a bunch of this query because I just want to look at that first Lab Apache access. When I click start, I notice, and particularly want you to notice, that in the field browser, I have all these fields available. I have a field called status code. I have a field called source IP, URL, all these different portions that make up this thing. IP address, that's a big one. Now, since these fields are available, this is letting me know that a field extraction rule is working. And what's happening is basically the system is looking for or waiting for any Lab Apache access to data to come in. When that data comes in, it knows automatically what a log message looks like. It knows the IP addresses first, then there's the time, then there's the status code, then there's the size. And so it can automatically parse out or extract those things for you to utilize. So this is why we can now say end status code equals 404, because the system knows what a status code is, it knows how to locate it, it knows the values for it, and so we can say status code equals 404. Versus what we were doing in the first lab, we were saying just end 404. Now we can say specifically, just look in that status code field. Now we see only 404 messages here, and we only see status codes that have 404. Now, in the same way, we could now count by source IP, which is saying count by this field. So now if we count all the messages that have 404s by IP address, now since we're doing count, we get that aggregates, and now we see those source IP addresses because those have been parsed out already. So field extraction rules really helpful for you to use. The big benefit of them, well, there's many benefits actually, but one of them is this simple search scoping, in that it allows you now to say, use an IP address, use a status code, where previously you would have to tell the system how to identify the status code and then go ahead and then count against it. So less steps, usually better. All right, cool. Any questions yet? No questions, so that's a good sign. So let's keep rolling here. Lab 4 is introducing conditional operations. So I'm going to take the query like I've been doing and copy and paste it. But the goal here is to write a query that scans through the Lab Apache access logs for the last 60 minutes and returns the number of successful HTTP requests, which are going to be a status code equal to 200, versus the error HTTP requests, which are 404. So I'm going to take this query, copy it, paste it in, but let me show you how it works, because it's a different approach, but it's really quite helpful. So let's go ahead, comment these off line by line. First line, Apache access. Again, Second line, we don't really need, because we don't necessarily have to tell the system how to locate a status code, because we had the field extraction rules working. But in this case, let's assume the field extraction rules aren't working. So that's why we have to parse out that kind of manual way. But either way, we've now parsed out status codes. To verify that, if I go to the status code field, I now see all these different status codes. Now here's where it gets a little relevant, I guess, to the use case in start to use these conditionals. What we're doing here is we're going to go ahead and create a column called successes. And what we're going to do is we're going to look at the status code. If the status code is equal to a 200 and that message is true, we're going to tally a 1 in the success column. If the status code is not equal to a 200, making the statement false, we're going to tally a 0. So now when I click Start, I have a new column called successes. And now if I have a 200, I have a 1. And if I don't have a 200, I have a 0. Now I'm going to do the same thing, or it's the inverse, but it's basically the same thing for 404s, where I'm going to create a column called client errors. If I see a 404, I'm going to tally a 1 for a client error. If I don't, I'm going to tally a 0 for a client error. So now when I click Start, for each log message, I'm going to have my status code, and I'm either going to have a success or a client error, or neither. So here's a 200, that's a success. Here's a 304, that's neither a 200 or a 404, so we see zeros in both. And then if I had a 404, I don't want to waste time looking for one, I would have 1 in the client error column. Now, what can we do with this? Because right now we just have a bunch of 1s and 0s. What we can do is very simply add them up. So we can take our successes and add them up and call it a success count, and take our client errors and add them up and call it a client error count. And now what I see is over the last 15 minutes, we've had this many successes and this many fails, or this many client errors. Now what we'll do with this is in the last lab, we'll tie all this together as a ratio so that we can start seeing how many good versus how many bad did we have and start to compare those in different time periods. But we're going to work up to that. So in lab 4-1, what we were showing is the equal syntax. Now in lab 4-2, what we want to show is the matches syntax. Basically the same thing, but here we're saying 200. So here we're kind of saying pretty binary. If it's 200, yes, no. But here we're saying matches. So if the status code matches a 4, is a 401, a 402, a 403, etc., count 1 for a client error and count 0 if it's not. And here we're doing 5s. So we can use these together. We could say if status code equals 200, tally a 1 or a 0 for a success. If it matches a 5, tally a 1 or a 0 as a server error. Just up to you. The other thing you can adjust is the values themselves. So maybe, let's say for this success column, right now we're using 1 true, 0 false, which is traditional binary, on off, but you can weight these. Maybe you want a success to be a 10 instead of a 1. Now when I click Start, my successes are now going to be 10x because I'm now counting them 10 instead of 1. You could do 5 and 3, or 2. You can do whatever you want, but 1 and 0 are traditional, but you can modify those if you want to. Okay, cool. Lab 5 is using subqueries. Now this is a lab that I'm certainly going to go through. But for subqueries, I really want you to remember conceptually what these do. Certainly, as we go through with the lab, you'll get some hands-on experience. But what a subquery does, and subquery itself is not a Sumo logic thing. So you may have used subqueries in other kind of worlds or environments, but they fall, to be pretty much the same. In that, they allow you to take one query, another query, and pass results to one query. So let me describe this better. What we have is the ability to do a child query. The query is going to run, it's going to produce a result, and then that result is going to be passed to the parent query, and then the parent query can continue to run. So in this example, let's say we want to run source categories equals lab Apache access like we've been doing today, and we want to look for an IP address. But rather than just defining a specific IP address, we want the IP address to dynamically or automatically change based on the amount of error messages showing up in our Apache error logs. So what we want to do is we want to look at our Apache error logs, see what IP address is occurring most frequently, and then pass that IP address as a value, or really as a keyword, to this Lab Apache access data and look for that IP address within that set of data. So how do we do that? Well, that's what the subquery does. So I'm going to go ahead and, let's see, I'll grab the whole thing. Let's do it this in kind of 2 steps. Here's the whole query, but I want to back into it. So I want to show the subquery or the child query first, which is right here. Okay. So here's the whole query. Here's the parent query. Here's the child query. But what I want to show is how the child query works and then back into how the parent query is using it. So in search 20, I have just the child query. So what the child query is doing, let's go line by line, be consistent. In the first line, I'm saying, look through the Lab Apache error data and look for the file does not exist, this string of text, because I want to find those error messages. Now what I want to do is I want to start to parse out the IP address specifically because I want to see what IP address is showing up most frequently. So that's what I'm doing in the second line is I'm saying parse out the thing in brackets first, call that time, this thing in brackets, call that error, and then this thing in brackets, extract just this as the IP address. Now I could do this just by using a regex rule that says look for number, which would work perfectly fine here, but we wanted to show just multiple ways to do this. So now when I click start, all 3 of these fields, time, error, and IP address, are going to be parsed out. But really, I just need the IP address field. Now what I'm going to say is count by IP address, because I want to see how many different IP addresses we have associated with these file does not exist messages. Now, before I click start, this lab does kind of fall apart a little bit here in that we only have 1 IP address available. But for this use case, I want you to imagine once I click start that there are 4 different IP addresses displayed. One that shows 100 values, one that shows 20, one that shows 6, and one that shows 2, or kind of whatever numbers you want to use. But right now, imagine this list is 4 long, or 10 long, or whatever length. We want to ultimately take this list of 4 long and find out which IP address is showing up most frequently. So what we're going to do here is use the top. Instead of using the top operator, we're using top K, which is very, very similar. There's subtle differences, but for now, it's similar enough is good. And what we're doing here is we're saying take the top K, the top what? Top 1. How do we want to figure out the top 1? We want to do it by count. And so now when I click start, I'm now presented with the single value that's showing up most frequently, which is this IP address. Now let's go back to the full query. So this portion that we just ran is producing a single IP address. And what we're doing right here is we're saying compose IP keywords. What we're basically saying is take the IP and compose it as a keyword and add it up here. So we're almost doing something like this. So what we're doing here in the middle is creating or generating that IP. Now that IP is being placed up here and we're searching across it in the lab access data. And now we could say something like within the lab access data, count by status code. And so now we're seeing all the different status codes that are associated with this IP address. So really what we're trying to show there is the fact that you can take a query, have it run, generate a result as a keyword, and then go ahead and pass that keyword to another query and continue on. And so this is where really conceptually I want you to remember how to do this. I don't really care for right now that you have to use the top K or the specific operators you need to use, but the fact that you can pass those values from one query to another is the benefit there. So wanted to show that. All right. Lab number 6. Lab number 6, I'm going to give you a few moments to play with. You probably have seen this demonstration of this lab previously, and this is how maps are created. But why don't you go ahead and grab the query, play with it for, I don't know, a minute or 2, and then I'll go ahead and jump in and explain it. So yeah, I'll give you 2 minutes to do it. The result should be that you get a map. So let's see if you can get one, and I'll give you guys a second to play with it. Right, so hopefully you were able to create a map, but let's go through this. Line by line again. So the first line, or really the first two lines, we're looking for the Apache access data, and then we're looking for those IP addresses. Once again, we technically don't need to do this second line because field extraction rules are already parsing out those IP addresses, but let's pretend they're not. So now what I see is for each column, let me clean this up, there we go. I see for each log message, I see an IP address. Now, what can we do with the IP address? Well, geographic information is associated with these IP addresses. When you go to a website and it presents to you the local news and sports and weather and all of that, that's how it's doing that. And so we're giving you the ability now to use that geographic information for your benefit. The way it uses it is on the third line. And what we're doing here is we're using one of our lookup tables. The lookup table we're using is geographic information. And the way this line reads easier is actually reading it from right to left. What I'm doing here is I'm saying take that client IP that I just defined and compare it to the IP addresses that exist within the geolocation lookup table. And from that lookup table, go ahead and extract out latitude and longitude. There are other fields you can extract out, such as city, state, region, country, continent, area, a bunch of other stuff. But for this case, we just need latitude and longitude. So now when we click start for each client IP address, and this only works for public IP addresses, we get a latitude and longitude pair. Now, what can we do with that pair? Well, what we can do first is count them. When I click count or when I click start, the system is now taking those latitude and longitude pairs and counting them up. Now what can I do with them? Well, now I can plot them on a map. So very simply now, if I click on the map icon, I now see of the last 15 minutes, these are all the visitors that are coming through us from the world, whether it's visitors, hits, sales, transactions, whatever. I now get a dynamic map showing me this, which is pretty cool. And that's what we wanted to show here, the ease of creating a map. I mean, we did it in about four lines of code, and technically we don't need that second line. And between the ease of it, or the easiness of doing so, and the impactfulness of it. I mean, this map is simple. Anybody looks at this map, they know this is where my sales or whatever are going on. And then they can react appropriately. Oh, maybe we're having more sales in Asia. Maybe we should promote, do a different promotion. Maybe people in the US are starting to wake up. Maybe we should do some breakfast promotion, or, it depends totally what you're going for. And so the map is easy to use, simple to understand, and not really hard to create, but very, very impactful, very powerful. Okay, no questions, great. Now, Lab 7, I'm going to skip over Lab 7-1. I show it very frequently. It's such a minor feature. It's not really that helpful. In fact, now that I've talked about it, I feel like I need to show it. So let's show both of these. The first one is Lab 7-1. And very simply, what this is going to let us do is calculate the difference in number of requests over the last 15 minutes. So what does that mean? What is this showing us? Now, I'm going to show the lab, but it's not the most important feature you'll ever learn, but hopefully you'll use it. So let's show what it is. First line, Apache access again. Second line, I'm using time slice, which I haven't used yet today. I'm just trying to think while I say that. Yeah. So what time slice is allowing us to do is take our data and break it out into chunks of time. In this case, 1-minute chunks of time. So what we're doing here is we're saying, go ahead and break our 15 minutes of data into 1-minute buckets or 1-minute chunks. Now the third line, what I'm doing here is I'm saying now count by time slice. Since I'm doing count, I'm doing math, I get the aggregates result. And what I see here now is for each time slice, each 1-minute bucket, I see the number of log messages. So this is saying that there were 25 or 2,700 log messages from 259 to 3, 5,000 log messages from 249 to 250, and so on and so forth. Now that's good, I guess, might be useful in some way, but let's show the feature, which is the diff. What I'm going to do in this fourth line here is just clean up the data. I'm just taking this time sliced data that's in essentially random time and just putting it in ascending order. I could do it in a descending order as well, and now I'm going to use this diff operator. What this is going to do is very simply show me the difference from one row to the next. At 247, there were 2,800 messages. At 248, there were 4,000. The difference between 4,000 and 2,800 is 1,200. At 248, there were 4,000 messages. At 249, there were 5,000. The difference between 5,000 and 4,000 is just about 945, and so on and so forth. Now, is that the most best operator you're ever going to see? No, of course not. But it may be helpful, and that's why we just wanted to point it out. Now, this next one, though, is much more useful. And what this one is going to allow us to do is calculate the moving average of 404 occurrences. So grab the query, paste it in. You guys know the drill. Comment off. All right. So what's going on with this query? Now, in the first line, we're saying, as we've started to do a few times already, we're saying look at the Apache access data. In this case, look at status codes equal to 404. So in this case, if it's not a 404, I don't care about it. Now I'm going to use the time slice. And now I'm going to count those results of the time slice. And what I'm doing specifically here is I'm counting as error count by time slice. But when I click start, now what I see is for each minute period, I see the error count or the amount of messages that have 404s. Same difference. I'm going to sort them. Now what I wanted to do here was the goal was to create a moving average. So what I'm going to do here is use the operator of smooth and try to not make a typo. What I'm doing here is I'm saying take the error count and smooth it and call the result rolling average. So when I click start, I have a new column for rolling average. At 249, the count was 106. The average of 106 is 106. At 250, 106 plus 130 divided by 2 gives us that. 251, 106 plus 130 plus 130 divided by 3 gets us that, and so on and so forth. So now we're getting a rolling average. Now this is good, and the lab actually wants us to do this bonus question of plotting this on a line bar combo chart. So I can go ahead and put this in a bar chart. I can go ahead and put it in a line chart, but the lab is asking me to put these in a line bar combo chart. So how do I do that? What I do is go to one of those options, either the bar chart or the line chart, doesn't really matter. Go to the settings and choose the option of change series. When I select change series, I can now change the chart types. So here I can say the error count, I want to make a column, but I want to make my rolling average a line. And now when I click save, I get the best of both worlds. So what I see here now is at the blue bars are representing the amount of 404s for that minute period. And then the line is representing the rolling average for time. So we get to see both. Now, we don't really go much deeper with the charting options in this class, but I do want to remind you that each chart does have its own options. Some of them are repetitive, some of them are not, but they're really meant for you to adjust the look and feel so that you can do things like change the legend. Do you want it on the right or the bottom? Modify colors. Maybe you prefer to use purple or fuchsia or whatever that color is. Just so that you and really more importantly, people that are going to be looking at this data or these messages can help, understand what the heck this stuff is. Okay. Lab 8. Lab 8 is logReduce. So let me just talk about it. And I hope you've seen logReduce at some point because it's really a feature here at Sumo Logic that we're quite proud of. So let's talk about what it does, why it's helpful, and I guess why we're proud of it. So I'm going to pull up this snort data, which is that security event data that we used earlier for the different IP addresses. But in this case, we're going to use it for a different purpose. And the purpose we're going to use it for is more of the intended purpose of these messages. These messages have classifications of different security events. So here I see classification attempted information leak. Here there's a bunch of attempted information leak. Here, web application attack. Here, classification of sensitive data, and so on and so forth. And so over the last hour, there's been 6,000 of these different security event messages. Well, let's say I wanted to get a quick understanding of the different classifications that have occurred over the past hour. Now, how am I going to do that? Because I want to do this quickly. The proper way would be to create a parsing statement where I say, look for bracket, look for word classification, look for colon, look for space. This is the classification. Count all those and show me the results and then see how many of each one we have. That would be the proper way to do it. But that would take some time. Not a lot of time, but some time to do. What we want to introduce here is logReduce, because logReduce is going to take these log messages. So I'm going to click logReduce. It's now taking those 6,000 log messages and looking for patterns within them, and then grouping the messages together based on those patterns. And in this case, it's going to be promoting the patterns or using the patterns primarily around the classification. So what we now see is, of those 6,000 messages, 3,200 of them, or about half of them, were classifications of attempted information leak. 690 of them were classification of sensitive data, and so on and so forth. logReduce does exactly like I just said, takes those messages, looks for patterns, and then groups them together. It's a really great feature, and a really important feature for Sumo Logic, because it's actually what we got our first patent on, is this logReduce feature. And so what it's doing is it's using patterns, AI, secret sauce, algorithms, all the fancy tech speak, and looking for those patterns and grouping them. So now I see that there have been 3,000 attempted information leaks over the past hour. And I'm going to use this to go until now lab 9. So lab 9, I'm going to use the example. Yeah, I'll keep using the example that I'm with. Here we're just using a different set of data, but I'll just keep running through the same example. The ideas behind it don't change, just the results do a little bit. And so what I want to do here is I want to introduce LogCompare, which is what lab 9 is going to do. So at this point, I now have my snort data for the past hour, so about 2 o'clock to 3 o'clock Pacific time. And I have the patterns logReduce. So now I know over the past hour, there have been about 3,000 or 3,300 attempted information leaks. Now, is that a lot or a little amount of attempted information leaks? Giving you a second to think about it. And hopefully you're saying, I don't know. And hopefully the reason you're saying it, I don't know, is because you don't have anything to compare it to. While 3,000 attempted information leaks in an hour sounds like a lot, it depends on the environment. If it's me and I just have a small server in the back room of my mom and pop shop, that probably is quite a lot of attempted information leaks. If I'm Google, it's probably a millisecond that they see that many attempted information leaks. So it depends. And we need to compare it to something else to see how it depends. And that's what LogCompare is going to do for us. When I click LogCompare, it's now taking the current period of time, so 2 o'clock to 3 o'clock today, going and doing a 24-hour shift, so looking at 2 to 3 o'clock yesterday, and looking at all those log messages, and then grouping both periods of times together. So basically, we're going to 2 o'clock to 3 o'clock today, looking for the log messages, grouping them. 2 o'clock to 3 o'clock yesterday, looking at the log messages, grouping them together. And then what we see is what we call delta percentage to show us the increase or decrease of those messages. So what we're actually seeing here is we've seen a decrease from yesterday to today by 0.87% of attempted information leaks, meaning we have less of them than we did today. Well, that's certainly good to know. Conversely, we've seen an increase of sensitive data classifications by 7%. Well, that's probably also good to know that we're seeing those. And that's what LogCompare is letting you do. Compare data from one time period and another period. Now, maybe in your world, comparing Monday afternoon to Tuesday afternoon doesn't really make sense. You compare week over week. Well, you can just modify the time shift to be minus 7D. And now I'm comparing Tuesday afternoon to last Tuesday afternoon. Run just to see the results. And now I can see, oh, well, since, from last Tuesday to this Tuesday, it's increased by 0.88%. The other thing we can see here is, let me see if I have an example. Oh, I do, perfect. We can also see those things that are new as well as gone. So new is letting us know last Tuesday from 2 to 3, we did not have any of these attempted denial of service messages, but today we have 3 of them. Conversely, we see gone, which is letting us know last Tuesday, we saw a detection of a network scan. Wasn't it? Sorry, my mouse is being a little weird. Highlight it. I don't know why it's not letting me highlight. The line 14, we see gone representing last Tuesday, there was a detection of a network scan, which today there is not. So this lets us know both things that are new that have not previously occurred, as well as things that have previously occurred and are not occurring anymore. One other thing we can do here, or really 2 other things we can do here, is we can use this absolute value of this percentage. So for example, here we're seeing something increased by 0.88%. Now, do we care that it increased by such a small amount? Well, we may, of course, but let's say we don't. What if we only want to see things that have increased or decreased by 25% or more? Because that's more meaningful. Maybe 50% or more, maybe 100%. You know, you can decide what values. In fact, in this case, I don't have anything that's 25% or more, so let me use a different example. What I'm going to do here is I'm going to say, show me where it's 10% or more. Take the delta percentage, perform the absolute value against it, and only show me where it's 10%. So what I'm doing here is saying, show me things that have increased by 10% and more, or decreased by negative 10% and less. And so now when it's finished running, now we see only things that have been more impactful. We can also modify the query to just show us where things are new. So now this is only going to show me things that are new from last Tuesday from 2 to 3 o'clock compared to today from 2 to 3 o'clock. And so what this is saying is last week there were not any of these, and today there are these. And then typically you want to know when something's new because it's not always good that it's new, and then you want to kind of dig in to see, you know, where's it coming from, and are we going to expect more of these, and, you know, just going through the process that you guys go through for these type of things. So I wanted to show logReduce and logCompare. They complement each other. LogCompare is basically logReduce data in 2 different time periods, but really a great way and a simple way for you to start to compare data. Because now I really haven't, you know, written much of a query. In fact, I really need to write any query because you just use the buttons here. And I'm now able to compare 2 different time periods to see, are things getting better or worse, and then making a decision, but I'm not having to write lines of code, which is good, always good. So want to make it easy for you, and these are certainly some great ways to do so. Okay. Lab number 10 is outlier. Outlier is a really great feature. So let's go ahead and let's grab the query and just talk through it. Okay. So in the first line, I mean, these just get more repetitive, but the first line we're saying, look for the Apache access data, and of that data, just look for status codes that are equal to 404. And what we're going to do now is run a time slice. So we're going to put those in buckets, and I'm actually going to just do a little bit more data, bigger time range, just to get a little more data in there. And now in the third line, we're going to say, take the status codes, which are going to just be status codes of 404, count them, and call the result error count and do it by time slice. So now what I see is at 242, there were 117 error counts, or 117 404s. At 216, there were 138 404s, and, you know, so on and so forth. Now, as I've asked a few times, and I like to ask a bunch, 117 404s in a minute period. Is that a lot or a little? Well, once again, you should probably kind of say, I don't know, because it depends. And here what we want to do is have the system help us determine that kind of it depends portion. Because we could just say that that's high or low, but we want the system to evaluate it, particularly in relation to other stuff going on. And that's what outlier does. Outlier allows the system to take the results, look at them, look at previous data points, and start to develop a range of what is considered acceptable. So here in the last line, I'm saying take the outlier, and that's the operator that does this threshold, perform the outlier against the error count, and then use a bunch of math to determine the range. And I'm going to leave it kind of vague as math for a moment, but I'll go into that math in a second. So now when I click start, the system takes the math and starts to look at the other values and develops a range. So here the error count was 148. The system using math has said, okay, an acceptable range or a normal range of 404s is 95 to 166. 148 is within that range, and so that's considered good or normal. Then the next time period, 1 minute later, the range changes a little bit. It's a little more narrow just based on the math, but it's still within that range. If we fast forward to line 8 here, we see the range is now 104 to 156. The actual is 159, and so that's outside that range. And so what we see here is a 1 representing an error count violation. Now, while it's good or okay to see it this way, the system's letting us know, hey, there may be a better way to express this data. And that better way may be through a line chart. So if I click on line chart, now I get a graphical representation of those outliers. And what the system is now showing me is over the last 60 minutes, there have been 5 times where the values have been outside the range. The dark blue line here, or darkish blue, is representing the error count for that specific minute period. So here it was 117, here it was 153, etc. The light blue cloud is representing the threshold based on the math, the upper and lower limits. And then the pink triangle is letting us know when we're outside that limit. So here, for example, the threshold or the range was up to 162. The actual is 168, which is outside that range. And so that's why we see the pink triangle. And so what we're seeing here is 5 times where the 404s was outside of what's expected. Now let's talk about the math for a second. Math is going to give us the ability to adjust how all this calculation is occurring. So for example, let's start with direction. Direction is showing us plus or minus above the cloud. Well, let's say in this case, we have less 404s than were expected. Now, do we want to be notified when we have less 404s than were expected? Once again, of course, it always depends, but let's say no, we don't. We can change our directions to be, instead of plus or minus, just be plus. And now when I click start, now I only see 2 times or 2 outliers over the past hour, because those are the 2 times where we had more 404s than were expected. Now with the math, you can start to change how the cloud or the threshold is calculated. The window, for example, is going to allow you to decide how many trailing data points do you want to use. The consecutive, consecutive, I'm going to skip over just for a second. The threshold, this is the big one, this is going to allow you to control how many standard deviations are used to calculate that threshold range. And if I change it, my values or the range is going to change. So let's say I change this from a 2 to a 3. Now, instead of having 2 outliers, I have no outliers because the numbers haven't changed, but the calculation for that threshold has. Conversely, if I change the threshold to a 1, now instead of having 2 outliers, I have, 15 or so there. The numbers haven't changed, that the value or the calculation for the threshold has. And that's what this is showing us. So wanted to point out outlier because it's a really helpful feature to let the system do this automated calculation. Because you might just say, okay, well, outlier is great. Why don't I just set an alert if I have more than 200 404s? And you can. The system will allow you to set an alert for more than 200 404s, but the problem with that is it's not dynamic. It doesn't grow with you. Because while 200 404s might sound like a lot today, what if your traffic grows 100x? 200 404s might be nothing. 2,000 404s might be nothing. And so this allows you to, or the system to dynamically grow with the data. As the data increases or decreases, the range is going to increase or decrease appropriately. Strongly encourage you to use this. And this is another example, kind of like with Subquery, where for today, I don't want you, or it's not necessary to remember all the details of what window is, what threshold is, etc. But really more, if you're thinking down the road, oh, I wish there was a way to establish a threshold of data, oh yeah, outlier, and then look at the documentation on how to use it. So really helpful feature, really lets the system do the calculation. And there's a great thing to make alerts off of so that then you can be notified about these things in the future. So that the next time you have more 404s than are expected, you can get an alert. And I'll show you in lab 15, we'll actually kind of tie all this together and look at generating an alert from the system for these type of things. So that's outlier. Lab 11 is predict operator. Very similar, but it's prediction. So rather than looking at previous events, it's going to allow us to look forward. So to use it, it's pretty much the same query, just minor difference. Rather than using the outlier to look at old stuff, we're going to use the predict operator. So just to kind of reset ourselves, if we look at the first 3 lines, we're getting the amount of 404s, the amount of 404s for the past time periods, and now we can start to predict. By predict, the system is now using prediction modeling to start to determine what to expect in the future. And so here we see the past and the prediction modeling taking place. And if we fast forward a little bit, now we start to see the modeling take place. Here it's expecting 128.9 404s, 128.7, 128.5, it's trending downward. If we choose the graph, particularly the line chart, now we get that graphical representation. So what we see is here's the light blue are the 404s that have occurred over the past hour, and the dark blue is the modeling line. And the modeling line appears to be trending kind of downward. I mean, it's pretty flat, but it's downward, which is good because this would mean in the future, we're expecting less 404s than have been occurring. That's a good thing. If this had been trending upwards, that would be a bad thing, meaning we're expecting more 404s. And what we could do is we could take this panel, this graph, this chart, and save it to a dashboard. And so it could appear on a big screen showing the prediction modeling. And so if this is showing trending upward, well, hopefully someone's aware of that and they're trying to mitigate against that prediction turning into actuality. And so this could be a helpful way to start to see what the system is anticipating. There's actually two different modelings that you can use. I'm not going to go into details on those, but there is two different prediction modelings. There's an autoregressive model and a linear model. It gets very math-y, once you start to dig into it. But people who are really want to nerd out on that stuff do appreciate that. So I'm not going to go over the details of those because, to be honest, I'm not even sure of them myself. But they are used in different use cases. All right. Lab 12 I'm going to show. I don't love this lab, but I love the theory or the principle behind it. So this lab is not the greatest. I need to rewrite it a little bit, but the feature is pretty cool. So let's show it, and I think you'll get at least the gist of it. Lab 12 is going to allow us, or what we're trying to do with Lab 12 is analyze related log messages. So what we want to introduce here is the transaction operator. And what the transaction operator allows you to do, or allows the system to do, is to look at a bunch of messages and group them or analyze them based on a unique transaction identifier, as we call it. So something that's going to be unique in the system, like a session ID, an IP address, an order number, maybe a phone number, depending on what PII you're collecting. And what you can do is you can then group messages in different states based on those unique identifiers. So what does that mean? Because that description is a little weird. Basically, what you can do is you can see different states that people reach during a process. So in this example, we're going to imagine that we have an e-commerce website called eComMark. And what we want to do is we want to see how people are interacting with the e-commerce website. And so what we have, here's the big query, but let me talk through it. And like I said, the example's not great, but you'll still get the gist. So in the first line, I'm saying grab the eComMark data and look for an IP address. So look for this pattern of number, that number, that number, that number. And then transaction on that IP. So use that IP as that unique identifier. Now within those log messages, look for different strings of text, and these strings of text are going to identify different states. And when I say states, I mean different stops in the process of checking something out. So you've all used online checkout services before. I'm sure we've all purchased something online. You know that there are different states or different steps, if you will. First, you put something in your cart, then you check it out, then you enter your billing information, then you enter your shipping information, then you confirm the order, then it gets shipped, all these kind of states or steps. What we have the ability to do is start to recognize these different states. And what you can ultimately do with this is count the different states. Let me get some more data to get a little more time. Now this is where the lab falls apart a little bit, but so now I have all these different states. These many people went from cart to order shipped. These many went from order shipped to cart, so on and so forth. What I can do with this though is I can modify the diagram or the chart that I'm going to use and use a flow diagram or a Sankey diagram as it's known. And what I now see, this is a little messy, but I think you'll get the gist, is these many people reach the carting step. These many people reach the shipping info step. These many people reach the confirmation step, etc. Now, I can't tell you why we saw a drop off from people that carted from people that reached shipping info, but that's where I can tell you there's a drop off, and then you would need to figure that out. So what we see in this diagram, I like this one a little bit better. We see a bunch of people carted, a bunch of people reach shipping info, and then we see a big drop off into confirmation. Now, I can't tell you why there's a drop off to confirmation, but I can tell you there's a drop off to confirmation. And now what you can do is try to figure out why. Maybe people are finding when they reach the shipping info step that shipping just is too expensive. Maybe the UI is confusing. Maybe they're getting an error. Maybe they, maybe, we don't know, but we can tell you what's happening and then you can try and figure out why. So transaction is really helpful to start to look at these different states, group them into states that you define, and then see how many people are getting to this step, how many people are getting to that next step, and then for you to go back and try and figure out why they're not getting to that next step. So this is another case like outlier. I don't remember you to expect, remember all the different things about results by flow or states, because I went through them pretty quickly. But really down the road, if you're thinking, oh, I wish there was a way I can use some unique identifier to group these messages together, transaction is going to be a good place to start. So quick overview. It's really a quite powerful feature. A lot of people use this and love it in our system. So certainly you might come across it. But if you do, or when you do, I would just take a look at the help because it just describes it a lot better. All right, 3 more labs. Oops. So the last 2, or 2 of the last 3, are around metrics, lab 13 and 14. So I'm going to do this as a pretty quick overview. For those of you that are not aware, certainly, while we have been talking about logs, for the first hour and a half, we can handle metrics. And so that's what these next 2 labs are going over. That being said, if you're interested in metrics, these next 2 labs will be just a quick overview, but we do actually have a separate class called Metrics Mastery where we really dig into metrics. So this is meant to just be an overview, kind of just to pique your interest and remind you, hey, you can do metrics in Sumo Logic. So let me run through this pretty quickly, but not too quickly. So what are metrics? I'm assuming you know what they are, but that's not a correct assumption. Metrics are going to help track KPIs, or key performance indicators, over time. They're typically more number series based. So let's say your logs, let's say we look at the Apache logs we're looking at. The Apache logs might show this user from this IP address went to this website on this date and got this page that was this many bytes. Where the metric might be pages visited, 1. So it's more of number series where the logs are typically more verbose. So let's take a look at the metrics interface quickly, not to rush through it, but just to give a quick overview. So, and let me just grab one of these. So today we've been going over new log search, and many of our customers do, but we also have new metrics, and that's what we're going to look at right now. The metrics interface is similar. It's also quite different. So it's similar in that it has a graph. The graph is at the top. It has a query language. It's kind of more towards the bottom. It has time components. So it has, similar functionality, but it is a little bit different. So in this case, let's say we have a travel website and we want to check to see all the people that have booked online over the past hour. What I'm going to do here is in the query for metrics, I'm going to type this particular syntax. Now the query language is different. It's also similar. So rather than doing source category equals like we were doing for logs, in this case, we're using type is equal to. So here we're saying we want to look at the type of bookings. And for the bookings, we want to look at the metric related to success count. How many successful bookings have we had over the past hour? And so what we see now broken up into 15-second quantizations or buckets, we start to see those successful bookings. So what we see here is 2:35, people are booking, happy bookers. And then what we see about 3 o'clock, we see a drop in successful bookings. We still see some successful bookings occurring. And then at about 3:30, or I guess 3:25, we see an increase in successful bookings. And the pink circle is representing an outlier, like we saw with the logs, except in this case, it's related to metrics. So what the pink circle here is telling us, things were kind of normal, and then they weren't. So that's what we see right now. So we see the metrics related to successful bookings. Well, what we can also do at the same time is bring in the metric related to failed bookings. Let's see all the failed bookings that have occurred over the past hour. And now what we see are both. So what we see here is at 2:30, 2:40, 2:50, people are booking successfully. Well, isn't this interesting? At about 3 o'clock, we see a drop in successful bookings. And at 3 o'clock, we start to see an increase or see any failed bookings. We see a lot of failed bookings as well as a drop in successful bookings. And then when the failed bookings stop, we see an increase in successful bookings. So that's what these metrics are showing us right now, which is pretty helpful. Now what we can do with Lab 14 is we can now look at logs and metrics together in what we call a ULM, or Unified Logs and Metrics environment. What we can do here now is we can bring in some logs. So while the metrics here are showing me people were booking successfully and then a bunch of failed bookings occurred, I don't know why that happened. And so what I can do is start to look at the logs related to, in this case, let's say the checkout service, and look for the word error within those logs. So now what I'm saying is look at the metrics related to success and fail, and also look at the logs related to the checkout service that have the word error in them, or the string and error in them. Let me see. Let me see how much when did it work. Oh, I'm sorry. It's in the wrong spot. So now we're saying look at the training, travel, checkout logs, and look at any errors that occur within those checkout logs. Well, look at this. Isn't this interesting? Up here at the top, we see log messages that have the word error in it. And this is a heat map. The darker the color, more frequent occurrence. So what we're seeing now is when people are booking successfully, there are no errors in the logs. At 3 o'clock, we see a drop in successful bookings. We see failed bookings occur. And at the same time, we see errors in the logs. Now, what we would probably want to do naturally is now dig into those logs to see what's going on. And that's where you can start to use the logs and the metrics together to help you to really dig in or diagnose what's going on. So this is a quick overview of metrics, but I wanted to show it. If you're interested in metrics more, like I said, the metrics mastery class would be great for you. As a user, or as a really customer rather, I also want to point out that metrics are available to you. In fact, we are trying to get people to use us for metrics. Well, people are using us anyhow, but to kind of promote that, we actually give you some free metric space. So if you are curious about, hey, I'm using metrics in another environment, maybe I should bring those into Sumo Logic, bring them in, try it out. If you think it's working, great. Maybe you can get rid of some other product. If not, no loss. So, and your account manager can certainly help you with all that about the pricing. All right, last feature. I know we did a lot in a short amount of time, but this is a good last lab, because this lab ties together a bunch of things we've looked at already into one kind of a mega lab, if you will. So the goal here is to create a meaningful alert. So what we want to do in this lab is, rather than alerting on simple counts, we want to create an alert that's going to notify when our 404s increase at a higher rate than our overall traffic. So that's the goal here, is we're saying, rather than let us know when we have more than 200 404s, we want to say, let us know when we have this many 404s compared to this many 200s. So how are we going to do that? Well, the query's here for us, but let's go through this. Now, you've seen all these steps, but together it turns into one great solution. So let's paste it in and just really go line by line. All right, so in the first line, I'm saying, look at the lab Apache access data and only grab status codes 200s and 404s. So in this case, we're saying 200 goods, 404 is bad, keeping that very binary. So now I have, for each log message, I have a status code, and the status code will either be a 200 or a 404. I'm not going to look for 404. Oh, there's one. There's a 404. Let me just modify this query just to get a little more data in here. So now I'm going to go ahead and use my time slice, because I want to start to look at this data in buckets. I want to start to see how many 200s and 404s did we have at 3 o'clock, at 3:01, at 3:02, and that's where time slice is helping me with. Now we're going to go ahead and use the conditionals that I pointed out earlier. So what we're doing here is we're saying, if the status code equals 200, if that's a true statement, tally that 1 for success, or tally a 0 for success. So when I click start, I have the success column, and I have either a 1 or a 0 in it. Now I'm going to do the same thing for 404s and fails, because remember, I'm either going to have one or the other. So now what I'm going to go ahead and do is take those successes and add them up, and take those fails and add them up. And I'm going to do it by time slice because I want to see how many successes did I have in 1 minute period? How many fails did I have in another minute period? And do it by time period. But I need a way to compare these kind of apples to apples because, as I've asked, a few times, I had 3,000 successes and 163 fails here. Is that better or worse than 2,600 successes and 117 fails? Well, I don't know. It's kind of hard to compare those two numbers. I need a way to do so. And so that's why we're going to go ahead here, and turn this into a ratio, or ultimately a failure rate percentage. So what we're saying here is take the success count plus the fail count divided by the fail count, multiply by 100, and now we get a failure rate percentage. So now when I click start, we're going to get a failure rate percentage for each minute period. Here the failure rate percentage was 4.5. Here it was 4.2. One is better than the other, and now I can start to compare those kind of apples to apples. Now I'm going to go ahead and sort these. And so now what I see is the failure rate percentages. But now I want the system to help me determine what is normal or what is not. And so now I'm going to use the outlier operator. So now I'm saying take that failure rate percentage, use the math, and start to develop a range of what is good or not, or what is normal or is not. If I move to the line chart, now what I see is over the past 60 minutes, there have been 2 periods of times where the amount of 404s are greater than the amount of 200s and the outlier is occurring. So these are 2 bad times, 2 bad things that have happened. Now that's good to know, but I still have 2 more, really 2 more things I need to modify the query with. What I need to do is to add this line. Because right now we're seeing those past hour that has had outliers in it. What I want to do is I want to modify the query with this line. What this line is saying is show me where the failure rate percentage indicator is greater than 0, meaning it's 1. So now when I click start, I am only going to get those log messages, or those time periods that had an outlier that were more than what was expected. Now this is good, but the goal here was to create a meaningful alert. Right now I'm getting meaningful information, but I'm not getting that alert component yet. And that's what I want to do right now to end this portion. So what I'm going to do here is I'm going to save as, and instead of saving the query, I'm going to choose to schedule the search. Then I can decide how frequently do I want the search to run. Now this search, I can have it run in real time, because what's going to happen is it's now going to notify me when the following condition is met, meaning the condition is the failure rate percentage indicator is greater than 0, meaning an outlier has occurred. So now the next time an outlier occurs, I can get an email, or I can get a Slack message, or any other type of alert that I want. And where this helps is now I can go ahead and the next time I get, or the system gets, an outlier related to the 404s, it could notify the web ops team. And maybe that web ops team now goes to their playbook and knows, hey, I just got an email about outliers being more than they should. I need to go to my playbook, and my playbook tells me to stand up a new server or reboot a server, or do whatever it tells you to do. And that's how we wanted to wrap up today, because what we wanted to show is the alerts as a mechanism to be notified what's going on or not going on within Sumo logic. And so there's a lot of power and value in being able to be made aware of your environment, your infrastructure, your architecture, what's going on, and not have to sit in Sumo logic clicking the start button all day. So now the next time this occurs, I get a message, or whoever is on my team gets a message, they go ahead and do whatever they do, and now they can now prevent this from getting worse, because now the proper people have been notified. And so that's how we wanted to wrap up today's lab portion, is with that lab, because it takes, like I said, a lot of things that we've done, turns it into an alert, which is quite powerful, and is really a great example of how the system can benefit you and your others. So from content standpoint, from a lab standpoint, that's really what I wanted to cover. The next portion we're going to do is we'll go ahead and start the exam. So as a reminder, for the exam, you're going to want to make sure that you log out of the training account and log back in with your corporate or your personal Sumo Logic account, because we want you to get credit for the exam, not the lab account. When you log in, you're going to go ahead and be brought to the home page automatically. go to certification, choose Search Mastery, and take the exam. The exam, if you haven't taken one with us before, it's open book, it's open resource, open internet. You'll have 60 minutes to take it. You won't need that much time. It'll probably take about half an hour, if that. It's going to consist of 30 multiple choice questions. You need a 75 to pass. You have more than one time. You can take it up to 3 times. If you need more than 3, just let us know. And it's important to note, or maybe important to note, this is all free. So this is free for you, free for your organization. There's no fee or anything like that. And your peers can join in the fun as well. So while we just went through Search Mastery, if you want somebody who wasn't able to attend today to go through and sit through the same thing you just sat through, you can have them do the prep. The webinar is a recording of me doing what I just did. And then the labs are, the portions that we just went over. So let's go ahead and start the exam. I'm going to leave the channel open for a little bit. Typically, I do try to leave it open for the entire time you're taking the exam, but I do have a personal issue that just came up. So I'm going to need to probably close the Zoom channel in about 10 minutes, but that won't impact your exam at all. So still continue to take it. So I'll leave the chat open for another 5-10 minutes or so, and then I'll disconnect. Thank you, everybody, for joining. We'll follow up. We'll send you a little email that has a link to some slides and some other kind of helpful tips. But hopefully you found this useful, and we'd certainly invite you and encourage you to join any of our other training sessions. So let's go ahead and get started, and if anything else comes up, just give a holler. But thank you, everybody, for joining. Oops, looks like there is one question. So oh, cool. Yeah, thank you for your thanks, Charles. And yeah, let's go ahead and get started. So I'll put myself on mute and pause my screen as well, but I will be here kind of lurking in the background for a few minutes. So thank you, everybody.